Dear student, good evening. Today we shall deal with some problems from your NCERT textbook. Some problems are based on average speed and one problem is based on equation of motion. Let's see the first problem. Joseph jogs from point A to other end B on a straight 300-meter road in 2 minutes and 30 seconds and then turns around and jogs 100 meters back to the point C in another 1 minute. What are the Joseph's average speed and velocities in jogging from A to B and A to C? Okay, so let's see. Consider this is the straight road. This is end A and this is the end B. Length of the road is 300 meters. Now, time for this distance is 2 minutes and 50 seconds. Afterwards, he turns around and jogs 100 meters back to a point C. From the point B, he turns around and jogs to a point C, which is at a distance of 100 meters from the point B. Okay? Now you have to calculate average speed of Joseph in moving from A to B and also average velocity while moving A to B. Then you have to calculate the average speed and average velocity in moving from A to C. Remember one thing, while doing such problems, ensure that all the parameters are in SI units. Distance has been given in meter, that is the SI unit of the distance. Time has been given in minutes and seconds, so you have to convert time into second because the second is SI unit of time. So for motion A to B, total distance S is equal to 300 meters. Time, let be T1, 2 minutes and 50 seconds, that is 2 minutes 50 seconds, that is 120 seconds plus 50 seconds, that is 170 seconds. We have to calculate average speed. Now average speed, you recall the formula? Average speed is equal to total distance over total time. So substituting the values, we have this bar read as average speed. So average speed is equal to total distance meter, total time 170 seconds, that is 30 over 17. Convert in decimal fractions. So we have 7 so 49, carrying 4, 7 1s 11. Approximate 1.7 meter per second. Now average velocity of the from A to B. Since the body is moving, the object is moving, Joseph is jogging in a straight line, therefore the magnitude of the average speed will be equal to average velocity. So average velocity from A to B is also 1.7 from A to B, that is the direction. So magnitude of the average speed and average velocity is same in this case. Now second part, A to C. We have to calculate average speed and average velocity for A to C. For calculating average speed, we should know the total distance. For A to C, total distance is equal to AB plus BC, that is 300 meter plus 100 meter, that is 400 meter. This is the total distance. Now total time, the time for A to B is 2 minutes and 50 seconds, that is 170 seconds. And for B to C, the time has been given 1 minute. So T1 170 seconds, T2 60 seconds, total time 230 seconds. This is total distance, this is total time. Let us calculate average speed to be total distance over total time. That is 400 over 230. Now let us calculate in decimal fraction. approximate 1.7 meter per second. This is the average speed. But for average velocity, now the displacement of the body is AC, because final position of the body is C, initial position is A. Now average velocity is equal to total displacement over total time. So let us calculate average velocity of Joseph. Total displacement, net displacement you can say, is equal to 300 minus 100, that is 200 meter. Total time, T1 plus T2, that is 170 seconds plus 60 seconds, that is 230 seconds. Now, average displacement, average displacement is equal to total displacement, we have to calculate average velocity. Average velocity is equal to total displacement over total time, that is total displacement is 200 meter over total time is 230 seconds, that is 20 over 23 seconds. Now please convert it into decimal fraction and get the answer. Now let us solve the third problem. A train is traveling 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far train will go before it is brought to rest. Now in this problem, initial speed of the train has been given 90 km per hour. Acceleration minus 0.5 meter per second, because the brakes are being applied, therefore negative acceleration being produced. How far, that is distance. ब्रेक लगाने के बाद ट्रेन कितनी दूर जा करके रुकेगी, यानी you have to calculate distance traveled by the train after the brakes are applied. Obviously, the train will stop after covering this distance, therefore the final velocity of the train is 0. Let's see. Initial speed of the body 90 km per hour. Acceleration has been given minus 0.5 meter per second square. Final velocity of the body 0 because it stops. Distance S has to be calculated. Now, all the parameters should be in SI unit. So let us convert initial velocity into meter per second. You can convert kilometer per hour into meter per second by multiplying it by 5/18. So 90 kilometer per hour is equal to 90 into 5/18. That is 25 meter per second. So this is all about the parameter given in the problems. Now the selection of equation of mole. Which equation has to be applied? You can see this is an example of velocity displacement equation. Time has not been given in it. Time has been eliminated in the problem. And you find out the equation. V square minus u square is equal to 2as. S has to be calculated. So substituting the values we have, v square minus u square is equal to 2as, or simplifying it we have s is equal to v square minus u square over 2a, or s is equal to, in final velocities, square of 0 minus initial velocity 25, acceleration 2 into minus 0.5. Now this is the negative value. Rs is equal to 625 over 1.0, that is 625 meter. So when the brakes are applied, the train will come to the rest after covering a distance of 625 meter. Okay, that's all today's. Please try to solve these problems at your home. Thank you.